All right, good morning, everybody. Everyone rest and relax from a nice night in New Orleans last night? Not a little groggy or anything like that? All right, well, I'm Michael Washam. I'm a principal cloud architect with Aditi. And on stage with me, I have Steve Goldberg, who is a cloud services engineer with RightScale. I have Nan Mulchandani, who is the CEO and co-founder of Scale Extreme. And in this session, we're going to do exactly like the title of the session says. We're going to give you a crash course in automated deployments for virtual machines on Windows Azure. So one thing to point out, this is kind of coded as a 400 level class or session, and it's closer to 3. But if you want to talk 400, feel free to come up after the session, and we can go as deep as you want to go. And we're also going to hang out in the Azure booth in the expo when it opens up later, and you can come by and ask us anything you want. So real quick introduction about Aditi. So one thing, I was actually on the Windows Azure runtime team a week ago, and I just recently joined Aditi, so I want to kind of plug my new company. What we do at Aditi is we're a solutions integrator. We help customers get up on the cloud. We differentiate with some hardcore design and user experience resources actually in the company, and of course we deliver scale and agility. Now that that's out of the way, let's talk a little bit about DevOps. How many of you have heard of DevOps? I mean, it's kind of the latest buzzword of cloud deployments. What you might have heard is it's really IT and development working really closely together during the product lifecycle. And that's pretty much the case. What it really means is in the cloud, you can do a whole lot of things in an automated fashion that you couldn't easily do before, so it's really silly not to take advantage of that. So if you're an IT professional, you're a developer, whoever you are, if you're responsible for deploying applications up into the cloud, you're going to be writing code. That's really the key thing of what DevOps really means. So the benefits is shorter development cycles, more agile. So if you can automate things, you can reproduce them faster, you can do more deployments, you can experiment in your company better. You can reduce costs. So if you can automate a task, you don't need to do it as much. It doesn't spend as much time reproducing the same environment over and over. If you're deployment issues, shared responsibilities between developers and IT. So just to kind of reinforce what this means, I want to show the traditional tasks of what you would do, how you deploy a multi-VM or a multi-server environment outside of the cloud with no automation. You know, everyone's done this before. So the very first thing you need to do is, of course, you're going to set up your network infrastructure. This may already exist, or maybe you're going to be laying cable. You're going to be setting up routers and switches, getting NIC card, getting all the drivers set up. From there, you're going to be setting up server infrastructure. This could be ordering servers from your favorite OEM, getting them shipped to you, opening up boxes, getting paper cuts, getting tape all over your fingers, then setting them up, making sure you have the right firmware updates, make sure you have the right RAID array drivers, etc. Then you have to install and patch the OS. I mean, someone has to, right? So you install the OS, boot it up, patch it, make sure it's all good to go. Then you're at the point where you can actually install and configure your apps. So you're going to all 7 of these machines in your deployment, installing SharePoint or SQL or your custom app, whatever it may be that you're deploying. And finally, you know, if you're doing this in multiple environments, your boss says, hey, great job on that deployment. Can you get another one? You know, we have 2 other teams that need the exact same setup, and we'd prefer them done by Friday. And you get to start over. Hopefully you can reuse a little bit of this, but for the most part, this is your job. Now then cloud comes into play. What's different about the cloud? How does the cloud save time and effort in this space? Well, the first thing, you don't lay cables, you don't set up routers and switches. You go to a web UI and you configure what your network should look like. And there's some software and hardware up in the cloud and someone else's data center doing this work for you. Then you create a virtual machine with the OS already installed. So I go through, I click a virtual machine, I say I want it on Windows or I want it on Linux, and it just kind of happens for me. I don't have to do all the drudge work of getting drivers lined up, etc. I do have to patch it, can't get away from that. Once it's booted up, you still have to figure out a patching strategy for your virtual machines, and you still have to install and configure your apps. So if you're installing SharePoint, you're still going to 4 different machines, installing SharePoint, configuring it, et cetera, et cetera. Same thing for SQL. And multiple environments, what this buys you now is we did save a lot of time with configuring the network, creating the virtual machines. So now your boss is going to say, you know, we need 2 new environments exactly like that, except since you saved so much time by being on the cloud, we want to buy Wednesday. So definitely saved a lot of time just by jumping in the cloud. Now, whenever you're looking at cloud deployment from an automation perspective, you think of it differently. The first thing you do is you think like a lazy person. What is all the stuff that I do all the time that I don't want to have to do all the time? So you identify all the tasks that are repeatable. Anything that, if I'm deploying web servers all the time, maybe I should automate that. Maybe I don't have to go in and, server manager and add roles all the time. So identify the repeatable processes. Then I'm going to invest some time and energy into creating automation for those processes. So I'm going to create a script that can create a virtual machine that has IS on it or has ASP.NET or whatever. And then when I'm ready, I just hit F5 and run the script and it's done. That's kind of the beauty, the difference between deploying in the cloud versus deploying in automation in the cloud. And of course, there's always going to be tasks that aren't worth automating or that you don't think are going to be automatable. And those are, at this point, when you're going to do them, perform the non-repeatable tasks. And finally, if you want multiple environments, if your boss says, hey, we need this, 2 more deployments just like this, and we need it by Tuesday, yeah, whatever. You change your variable, hit F5 again, and you're done. So what tasks are good for automation? So tasks that are repetitive. Web server for dev and test is a perfect example. If you're deploying web farms all the time for, you deploy this latest app for this team, make sure it all works, tear it down, and then spin it back up again and redeploy. Tasks that are complex, deploying, the SQL team says deploying HA is simple and easy, but yeah, I differ with that. So whenever you set up SQL Server in an HA mode, you want to do it well and you want to do it once. That way you can go back and run a script and redo it again later. Tasks that can save you money. So Windows Azure Virtual Machines just announced that whenever you stop a VM, they're not going to charge you anymore. So you don't actually get billed when the VM is stopped. So whenever your developers and testers go home and they have a bunch of VMs up in the cloud, why don't you have a scheduled task that just goes and turns those machines off, so you're actually saving yourself on your bill. And domain expertise. It's a really good example. Security hardening. Say you pay that's not good. Say you pay a company to come in and do a review, security audit of your machines, and they write a paper that tells you exactly how your machine should be hardened and tightened, and then they leave. They take that expertise with them. So you review their paper, and some of it makes sense, most of it makes sense, but then you get to a couple of things that are ambiguous. What do, right? You have to call them back. You may not have access to them, so there's a big chunk of information you could have just lost. It may have been better, probably would have been, if they would have just given you a script that they could run that generates a report that tells you what you need to do. So where does Windows Azure Automation fit in with all this? What does a platform provide? So Windows Azure as a whole, the heart of it, the kernel, is the Windows Azure Fabric Controller. This is basically the piece of software or pieces of software that know how to automate the data center inside of Windows Azure. They're the ones it's the code that spins up servers, it sets up your load balancer, switches, all the good stuff that you don't have to do anymore is all done by the Fabric Controller. Now, how the Fabric Controller knows what to do is via the Service Management API. And Service Management API, or RDFE, Red Dog Front End is the internal name for it, is basically the API that other applications like the Windows Azure Management Portal use to talk to the Fabric Controller. So some good examples of clients. The Windows Azure PowerShell commandlets use the Service Management API to do all kinds of automation. If you're not a Windows person, you prefer to write code on Mac or Linux, there's a cross-platform command line interface that does the exact same thing. And of course, there's rich apps and services such as Scale Extreme and WriteScale, which we're going to talk about here in just a little while, in addition to the Windows Azure Management Portal or System Center that all build all these rich services on top of the Service Management API. So a little bit about the Service Management API. It is a REST API, so post, put, get, delete, all that good stuff is basically the core operations of how it works on resources in the cloud. It uses X509 certificate authentication. So if you have a certificate installed in your subscription, you pass that subscription in your request editor, and that's how the API knows that you have operations access on the API. Calls are async, so if you're making a call to a Service Management API, you don't get a result back that says whether it succeeded or failed. What you get is an operation ID, which is basically just a GUID. You take this operation ID, and then you call another API to check whether that succeeded or failed. And finally, the API is versioned. So whenever you build your app, you write it against a specific version of the Search Management API, and this is usually done by the date that that version of the API was deployed. And you know your application works even whenever they update their API, add features, deprecate features, your code will not break. It's tested against a specific version, and that means whenever you want to take advantage of new functionality, you update that version API too, and you'll see the new code. So let's jump into a real quick demo of just how the Service Management API works. So I have a simple ASP.NET application here. As you can see, it's pulling back some useful information about Windows Azure. It's showing how many cores I'm currently using, how many cores are available in my subscription, cloud services, and cloud services available. So this is making an API call out to our subscription API, or the Windows Azure subscription API. I can also call list virtual machines, and this is making a multiple calls. There's not a single API call to just list all your virtual machines. It calls out to a get service API, and then take the service name, and then it calls get deployment. And even better than the Windows Azure portal is how I look at this, not really. You can do a lot of different operations on your virtual machines. You can log in, reboot, shut them down. Basically, everything you can, the management portal can do, you can do on directly. So if you wanted to write your own custom portal to automate things or your own custom code, you can do the same thing. So if I want to create a virtual machine, I'll show you a little bit what the API expects from a payload perspective. Slowly. There we go. So this code actually is going to walk through creating a virtual machine. So the first thing I need to do is give it a cloud service name. This is a unique host name your DNS goes into. So my VM service 123A does have to be unique. Then I'll name my VM. So my TechEd VM 1, and give it some really super strong, unhackable password. And then the other thing you can see in this drop-down is a really long list of all the virtual machine images. This is the same image list you see in the portal. Actually, this one is not filtered, so the portal is going to show you some filtered images. And if you see from the API, you can see all the RightSkills images in there. So they were trying to hide them from you now. So I'll go ahead and pick Windows Server 2012 and click Create VM Configuration. And this is going to generate the XML payload that the APIs are used to actually create a virtual machine. So as you can see, here's all the configuration I just passed. My super unhackable password. Automatic updates are set to false. I don't have any networking endpoints. I don't have any data disks at the moment. But you can see here is the storage count where my data disk or my OS disk is actually going to be created at. So if I go down and I add a data disk, and then I add say an RDP endpoint, you can see that the only thing I'm really doing here is munging the XML. I'm adding input endpoints to the XML. I'm adding a data virtual hard disk to the XML. This is all the API does, is it creates a role as a big XML object, and it posts it to the API. And updates work exactly the same way. So now when I go to create the VM, it's going to make a call out to the Create Deployment API, and I'm going to get an operation ID back. I'm actually not going to get a success or failed that the virtual machine was created, just this GUID. So how I implemented my status checker is, you can see at the URL, the request ID is at the top. That's the operation ID I actually get back. So if I want to check it, I just run this page again, and it tells me whether it's in progress, completed, or failed, or whatever. So that is pretty much a very small introduction to the Service Management API. Now let's talk about a client that actually uses this API. How many of you have ever used the Windows Azure PowerShell commandlets? A few? So the Windows Azure PowerShell commandlets are a really powerful client that you can use to automate Windows Azure. You can automate query, managing, configuring Windows Azure resources, not just virtual machines, but you can automate cloud services deployment, websites, storage queues, databases, et cetera, et cetera. Works across multiple subscriptions and multiple data centers. You can provision fully composed virtual machines, which is a really big plus whenever you're trying to deploy at large scale. So if you go to the portal, you create a virtual machine, you then have to go add an endpoint, then later you have to add a disk. From PowerShell, just like what we saw in the portal, or in the previous demo, you can create the entire virtual machine as is in one shot. You can create it domain joined, and kind of a new feature we just added is whenever you create a virtual machine, remote PowerShell is going to be enabled by default. You can, of course, disable this, so if you don't want remote PowerShell, but you can turn it on by default. So once the VM is booted up, you can actually log into it and do something useful with it. Networking, you can configure and manage your virtual network settings and create VPN gateways. And we just feature a new feature that was added just last week is the ability to add access control lists on public endpoints. So now whenever you open up port 8080 or port 1433 for SQL or whatever you want to do, you can actually lock down which IP address or which network can access that endpoint. And finally, you can manage storage and upload all your virtual hard disks. So you can copy these between subscriptions or upload and download them or whatever you want to do. So let's jump into a real quick demo with PowerShell just to kind of show you how it works. And what I'm going to show is this is how you could create a virtual machine. So this is pretty much the same code or same kind of information that you saw whenever I passed into the service management API. I'm passing the service name, the virtual machine name, the data center location. In this case, it's going to be West US, the username, and the super unhackable password, and of course, the OS image. And then you type in, create new Azure VM config, you add the provisioning config, you open up an endpoint. It's a lot of work, as you can see. I mean, you're going to figure out how to do this. It's going to take you some time to, this is not super simple. But the beauty is, once you figure out how to do it once, you can just run it over and over. Every time someone wants a new virtual machine with a 80 endpoint open and remote PowerShell enabled, all you have to do is change your parameter and hit F5. And to show that, I'll go ahead, because I already have this virtual machine up and running, so I'll go ahead and change the service name and hit F5. And literally, within 10 minutes, we'll have a new VM running. I don't have to touch the portal. I don't have to add endpoints, anything magical. I just have to write this code, change the parameter, and run it, and it works. Now, let's look back at this virtual machine that was previously created. So this has remote PowerShell enabled on it. It's just a remote PSVM1. It's just a Windows virtual machine running up in the cloud, has remote PowerShell on it. So I want to show you a really quick example of how you can use remote PowerShell to manage or configure these VMs after they're deployed. So I'm going to create a new PowerShell session. So anytime you connect to a virtual machine via the API or PowerShell, you always need the service name and a virtual machine name. So I'm going to call a commandlet called get Azure WinRM URI. And what this is going to do is it's going to return back the URL that tells me how to connect to remote PowerShell. So as you can see, basically we enable remote PowerShell on a random port. So this commandlet actually goes off and figures out which port that is and returns back the string, so you don't have to go look it up ahead of time. From there, I can call, actually I need some credentials. I can call invoke command, give it that URI, give it the credentials I want to execute, and now I can actually execute a script. So what I want to do is install IS on this server. I already have a script that will do that. Oops. Need to have quotes there. So this is a real simple script that basically uses the roles and features API, installs IS. So I'll go ahead and hit, that's actually not going to work at all, is it? There we go. So I'll type in my username and my super secret password when it prompts me. And it's going to log in via remote PowerShell, and hopefully I didn't type in that password, and execute the script. So this is good. It's more automated than before, but I'm still getting prompted, and I still have to do it after the fact. It is entirely possible to do this as part of the deployment. So I make one script. I deploy a virtual machine that has IS on it. It could have an application on it. It could do whatever you want to do. And to give one more quick example, I have another script here. Oops. Called web farm demo. So this is a real short script. It has this really nifty function called create VMs from config. This is code that I wrote that basically reads an XML configuration file that knows how to do a deployment. It's something if you really wanted to get into heavy automation, you'd probably write something similar yourself. And what that configuration looks like is, this is just all homegrown. This is nothing official. But it basically is an XML configuration that says I want a VM named ISWFE, or ISWFE. I want 2 instances of it using the Windows Server 2012 data center family. Instance size small. Here's my username and password. And I'm going to put a web instance on it. I'm going to have web deploy on it. And I'm going to run two scripts. First one is install IS, and the second one is actually to install web deploy. So when I finish running the script, I'll have at least 2 web servers that have web deploy enabled on them. So I could literally take a Visual Studio application, hit publish, type in my super secret password, and publish directly to a couple of virtual machines. And the cool thing about this script is it actually sets up web deploy to do content sync too. So if I have 50 servers, it would actually synchronize all 50 of them every time I do a deploy. So that's deploying to a web server that's never been RDP'd into. It's not a custom image, it's a base image. It's just been fully automated to look like to be a web farm. So if you want to learn more about PowerShell, there's a session later today, 2:45 to 4, where I dig straight in, start from the beginning, and kind of go deeper onto it. So now that you've seen kind of what you can do right out of the box with Windows Azure, I'm going to bring up Steve Goldberg, who's going to talk about what RightScale can do.
Thank you. Sorry about that. That was a great introduction, and good for me to build on that, because that's what RightScale does. We're going to step up a little higher above the VM itself and talk about the capabilities and the automation that you have getting up to your software layers. So I'm going to try to minimize the slides here in interest of time. And what I'd like to introduce RightScale to you folks, for many of you who may not know of us. But what we do is we enable customers to very quickly launch application services in an infrastructure as a service cloud, like Windows Azure. One of the key, so we're not a cloud provider ourselves, but we sit on top of our cloud provider partners like Azure and AWS and Rackspace, and all in told, there's 10 of them today, public and private cloud providers. And we abstract all of the nuances of those individual clouds, their APIs, and the different services that they offer. And we provide an interface to those clouds, a single point of control, a dashboard, as well as an API. And so what's the value that RightScale adds on top of our cloud service partners? The first one I'd like to kind of brag about is just our experience. We've been in the industry for 7 years. We were the first to introduce cloud management into this space. So we were born when AWS was born. We've been doing this for a long time, and we've helped hundreds of customers launch almost 6 million servers to date in the cloud. And if we start in the upper right-hand corner there, that ease and quickness of deploying services begins in the multi-cloud marketplace, where we have literally thousands of assets, from pre-built server blueprints for things like your SQL Server or Couchbase NoSQL servers, or full .NET stacks and LAMP stacks, for example, where customers can just download into their account and customize them and go ahead and start launching those environments. Now, so these assets are what feed the configuration management framework in the lower right-hand side there. And the configuration framework essentially takes these assets, these server blueprints, and allows you to define your standard builds and codify your environment, your standards, self-document them, essentially, and repeatably and predictably launch these environments over and over again, regardless of which cloud you choose to subscribe to. Moving over to the lower left-hand corner, the automation engine is the second key part, in addition to the configuration management framework. And this is where we introduce built-in monitoring for things like the infrastructure assets, as well as the software services. And it's really not intended to be a visual monitoring environment. It's really meant to drive our automation framework. So we're going to be monitoring and alerting and trapping on thresholds that you get to set, and then taking action. And that action could be sending an email to an admin, or it could be running an automation script, launching another server, removing a server based on reduced workload, for example. Now you've got all of this automation happening, which is really what the cloud's about. And Michael did a good lead into that. The more you can automate, the better. That's really the key learning here. So how do you keep track of everything that's going on when it's not human-driven? And that's where governance comes in. And the first part of governance is access control. And we provide role-based access control down at the user level. So you can say that this individual gets to be the admin within this account, but this individual only gets to look at the billing and usage information and view-only access. So you can get pretty refined, and you could do that on an account-by-account basis. And in RightScale, an account would equate to a cloud account. So you would an Azure subscription, an AWS subscription, a Google Cloud subscription, and you manage those all in a single dashboard. Additionally, with governance is the ability to report and monitor usage. Who's doing what, where, on behalf of what service, and in which clouds, and within those clouds in what regions, and so on. So you get very detailed reporting that you can then extract into a common CSV file and take that information and bring it into your billing systems, or use a spreadsheet, for example, and do all of your kind of analytics against it. So we're going to jump into a demo. I just want to give you a preview of what that demo is going to look like. We've built a three-tier .NET stack in Windows Azure. We've made it production ready, so it's redundant at every tier. We've got a pair of software load balancers running HA proxy on CentOS Linux. Behind that, we've got a auto-scaling array, and I'll demo that, show you what that means. In the application tier. This is the IIS tier. And that's talking to a SQL Server tier on the back end. It's a mirrored pair, a principal and a mirror. And we've got a witness server for automatic failover set up as well. We're using Azure storage for our volumes as well as for our snapshot backups. And we're running the mileage stats application that hopefully many of you are familiar with from MSDN. Okay. So the first thing I want to do is to kick off, one thing that's not in the picture was a load generator. So in order to show you auto-scaling, I needed to introduce a load. So the first thing I want to do is kick off this instance here called load test, which is running HTTPerf. It's running in the Rackspace cloud. I would see my IP information. So I'm simply going to invoke a script that's part of this server's definition, and that exists in that blueprint I was talking about. And the blueprints are called server templates. That's the vernacular in RightScale. So I've got two scripts available for this instance to either start load generation or stop it. So I'm just going to kick that off now and jump back into, we'll do other things while we wait for that load to build up to a point where we'll start reacting to that load and adding servers to our pool. So what I'm showing you here is the implementation of that three-tier architecture that we just saw the diagram of. And hopefully that's visible to you guys. We're starting out with a pair of our load balancers. And everything's running in Azure US East. I can see under this resource ID column, second column from the left, that is the Azure ID that it assigns. So I can go back into my Azure portal if I need to and cross-reference it. On the left, or the right-hand side, pardon me, are a bunch of tags, which are very helpful, and we use those tags when we execute scripts. We'll check to see the state of these instances and take action based on tags that are set. So I've got my principal, SQL Server 1, and my tag reflects principal. I've got SQL Server 2, which is its mirror. And then we've got a witness server, just like the diagram showed. And then down here in the very bottom, you see an auto-scaling array for IIS. And this is a special construct where we can set policy that once we observe something happening, when we monitor something happening in the environment, CPU load, in my case, I'm looking at incoming packets per second. When it hits a certain threshold, and I can define that in my alerts, when it hits a certain threshold, I want to vote to grow that array. And that's how we do it. We take the members of that collection of servers in the array, and we'll vote to either grow or shrink. And when we hit a simple majority, we'll take action. This way we prevent one of those servers from spiking while the others are dormant, creating a growth experience when it's really just an unbalanced workload. So what I'm showing here under alert options is that 51% simple majority is when we're going to take action. We're going to do it against the IIS server array. And when we hit that threshold, we're going to resize it up by 1 unit, 1 instance. Similarly, when we hit a shrink threshold, we'll reduce that array by 1 instance at a time. And you can set these numbers to anything you want. So you can jump up by 10, 100, whatever, and reduce by any number you want. Looking up here under the server allocation policy, this is where I can set my minimum and maximum number of instances for this array. Minimum means that I'll never drop below 2 IIS servers for my highly available production environment. Should I drop below 2, we'll sense that and we'll automatically launch another instance to bring it up. So it's got a self-healing capability to it. So what we should see when that HTTP perf load generation kicks in is we'll start seeing these votes change, and I'm circling that in the lower right-hand corner there. Right now they're voting to shrink. We haven't reached that growth threshold yet. But since we're already at our minimum count, we're not going to shrink below the minimum of 2. But we're voting to shrink because there's no load just yet. So let's go back to our 3-tier deployment here. And let me talk about server deployments in a little bit more depth, or server templates rather. So for the load balancers, for the database servers, for the IIS servers, they're all using server templates. And these server templates are what I described in our marketplace. Let's go take a look at one for the database manager for SQL Server. Now these are fully versioned, so you can see along the blue bar on top the different versions in this generation. And you can customize them, update revisions, make any kind of changes, and have that reflected in a new version. You could always fall back to an old version if necessary. But the key thing to server templates is they're modular and they're extremely extensible. So this is where you can keep your VHD library very homogeneous and very, very simple and minimize it and do all your customization above that at a level that you can change easily. You can version it and you can change it at boot time if you wish. So let's dive right in. So a server template has really 3 key things I want to show you. The first thing are these images that RightScale has placed out there in all the clouds that we support, or at least support with this server template. So we've got this image here. It's called a write image for Windows 2008 R2, SP1, and it's SQL Server 2012 in that image. And this image exists, or this server template can launch an image in any of the clouds that I've listed here across the different cloud providers. So now you can build a standard configuration for a SQL Server, and regardless of where you launch it, whether it's AWS in Europe or whether it's in the US, or same thing with Azure, Rackspace, Google, you build your definition once, it's your standard build, and then you can deploy it in any clouds that you choose. So that's the multi-cloud aspect of the server template. The next aspect of the server template are the automation scripts. So this is where you can come in and add your PowerShell automation, like Michael was describing. We provide these pre-created templates automatically that you can clone. And you can go in and you can edit these scripts, you can delete them, you can add your own to create exactly what you need. But really, they're PowerShell scripts. And on the Linux side, we also use Chef and Bash and basically any scripting language that you're comfortable with. And you can mix and match them. Now, the last part that I want to show you about a server template. So can you see this is where we're starting to codify and self-document what this consists of. It's got version information in there. It's got what actions are, essentially a runbook automation is what you're seeing here. The inputs are the last thing I want to show you, and this is where you get the ability to, on the fly, at boot time, or at definition time, to set parameters. Like here I showed you the categories, and this is starting to look like a DevOps workflow here, because your storage team can set the backup parameters, your DBAs can set the database parameters, your network folks can set DNS parameters, and so on and so forth. And your developers, of course, can set the parameters for your application workload. And each one of those scripts that I showed you before, these are the inputs. These are the variable inputs for those scripts. So it's very parameterized, and I get to do things like determine what my backup retention period is, where my backup is going to go to, information about my database, such as my schema name, my fully qualified domain name, the mirroring certificate and passwords, the DBA admin password and user pass. So everything you need to access that database and run these automation scripts. Same thing with DNS. Who's my DNS provider? What's my username and access to that? And so forth, all the way down to the update aspects of my Windows servers, such as my knowledge base article or my key management server. And you can choose to set automatic updates on or off through these scripts. So let's jump back, take a look to see how our auto-scaling array is making out. Okay, we're still set to 100% shrink. As I look here, I've got 2 voters in my array, and they're all voting to shrink. So we're going to wait for that load to build up a little more. So let's talk about high availability and automatic failover of your SQL Server environment. So you saw that I had a mirrored pair with a witness server in the deployment, and it's running mileage stats. So here are my principal and mirror and my witness. I'm in my mileage stats app, which is being driven by this environment in Azure. And what I'm going to do is I'm going to update the database on the principal. Log in again. Beg your pardon. Wouldn't be a live demo without a little excitement. There we go. Okay. So I'm just going to change the name from Bond Car to Ski Rig. We'll save that change. So that's now been updated to the principal database, which, if I come back and take a look, is FFB8Es is the last characters in its Azure instance ID, which now allows me to fail that server. So simply I'm going to artificially do that by coming over to my console and seeing here is that instance ID highlighted, and I can simply shut it down. Okay, so while that's shutting down, what I expect to see is the tags on SQL Server 2 change from mirror to principal. And this is going to wait for SQL Server 1 to go red. So right now it's still shutting down. Okay, it's still stopping. This is where a little light music would really help. All right, so that's stopped. When I come back and refresh my dashboard, all right, so it's taking a moment to communicate back to the RightScale controller, which is in the cloud. We're a SaaS platform, so there's no software to download or install or manage. Okay, it doesn't want to cooperate. So we'll check in on that in a few moments. Let's go back to the auto-scaling array and see if that has discovered enough load to change its state. Okay, so something's happened. I'm now down to 50% shrink vote. So before I had two units, two instances, they both voted to shrink. Now I have one that's changed to its state from shrink to none. So it's noticing that there's more load than the rule states to start shrinking or voting to shrink, but there's not enough to vote to grow. Not yet. So we're still waiting for that load to build in the cloud. We'll keep coming back and checking that. In the meantime, let's go back to our database. Okay, so SQL Server 1 now shows inactive, and that's what the red icon indicates there. So if I come back to the application, to mileage stats, and I want to take a look at the dashboard again, I want to make some more changes, continue editing here. Come on. There we go. Okay, so I get the failure screen because the database that it was leveraging, the primary or principal SQL server, is no longer available. So as a good application, it presents a health check screen. And let's wait to see the recovery or the failover. Okay, so notice SQL Server 2, which was the mirror originally, and if I show you the tag, or you take a look at the tag here, it's now been upgraded or changed to principal automatically by the witness server, and using our automation scripts to do that failover. So now that that's providing database services, I should be able to come back into mileage stats. Sign in, and see the change that I made before. Come on. Okay, so it's still not yet available to service the load. Let's see why, what's happening here. Okay, that still looks good. Imagine, if you will, that okay, so let's come back to that and check our auto-scaling array while we wait for the application to come back. Okay, so no change there, unfortunately. It usually took about 5 minutes last night to get that change. But everything that's happening in the cloud, these actions that are happening, we're auditing and we're logging for you guys to to see what's going on, to troubleshoot if necessary. And we do that whenever there's an event that takes place. A script was run, and by whom. So I could look at my audit entries for any given instance that's running, or for an entire deployment of instances, and see all the activities that took place. When the user says NA, not applicable, it means that it was kicked off automatically. There was no individual that manually triggered an event or run a script. We can also take a look at what this system is seeing and why it's reacting the way it is, or not reacting at all. So this is the monitoring that's built in that I mentioned at the very beginning. And if I look at the interface statistics for now, and let's enlarge this. So according to my interface statistics, the load that's being generated, and I must have a caching phenomenon going on here because I'm not getting the load up to where it needs to be. I'm showing the blue packets, those are my incoming packets, are just below 6 packets per second. So I'm sending a lot more than that. I'm sending about 250 packets per second. So we've got some kind of caching phenomenon. But my rules are being obeyed, which is if there are less than 10 packets per second over a 3-minute period, I'm going to vote to grow. So if there were more than my minimum number of servers, I'm not using them. I don't want to pay for them. I want to shrink that array down. So I apologize for that. Without it seeing the necessary level of load, which in my case would be greater than 20 packets per second, we're not going to see it grow. But at least this explains why. So let's come back to our app. See if we can't get in. I think I know why. I think I need to update my DNS. So I have a script all ready to run and to do that. It's part of the server template. So let's go into that new Principal SQL Server, go into my scripts that are available for a SQL Server instance, and find the DNS script. There we go. So DNS register IP, the blue characters are the input values that I've provided in my input fields. Okay. It's given me a little note that it will appear in my audit entries, my log. I can also see in the little events table here on the left that it's been queued for execution. Let's check audit entries, make sure when it completes before we try our app again. Okay, it's preparing execution. Okay, it's running the script. And it'll tell us when it's completed. Come on. There we go. Okay, so it's completed registering. Let's come back into the application. Authenticate. And there we go. So I'm back into the application. I've got my new Principal database server. It shows the change I made here in SkiRig from Bondcar. So this demonstrates that we were able to replicate from the original Principal to the mirror, fail over to the mirror automatically, and still retain the changes that we made to the database. And I'm late, so Michael, why don't you jump back up? Thank you, everybody.
All right, so now, you guys change mics.
Yep.
Trying to wake everybody up. Almost. Okay, so let me introduce Nan Mulchandani. He's the CEO and co-founder of Scale Extreme, and he's going to walk you through what Scale Extreme can do from an automation perspective.
Great, fantastic. Well, thanks everyone again. So I'm actually just going to zip through a couple of slides here real quick, jump to a demo, try to do something a little simple so you guys, all of you here, can get started. So everything I'll show you here, as part of the product and things, you can set up a free account on scaleextreme.com. Try everything out that I showed you here. If you want some of the scripts and code, all of it is up there in the published as templates. So just at the broadest level, automation is the key part. I mean, this is a talk about automation, and automation is a sort of at the heart of everything we do. One of the key things about working with products like ours and Scale Extreme and RightScales is the idea that you kind of get a unified management sort of platform, not only for Azure, but also other cloud accounts you may have or systems, but also on-premise systems as well. So we're a SaaS-based cloud management product that gives you things like monitoring, patch management, as well as automation, but it cuts across different clouds and systems. So you can get a unified sort of approach and feel for all of those. And I'll show you that again as part of the demo. The other aspect is, there's sort of 4 components to when you're thinking about automation. Michael did a great job sort of outlining the reasons for automation, but all of it, as you saw, starts a lot with good design. So really thinking through what the constituent parts of your system are. What do you want to automate? How do you want to automate it? In our product, you design it. The second thing you do, obviously, is push a button, deploy it. The third piece, which all of us are familiar with, is operating it. So things like the care and feeding, locking it down, patching it, updating it, keeping it up and running. And then, of course, the last piece is the scaling piece. Scaling up, scaling down based on load. And then you kind of rinse and repeat. So for instance, when load gets too high, you go back to the deploy phase, you provision more servers. When load gets low, you go back to the deploy phase and shut things down in sort of the right way. So, cutting across these 4 things, you really need to be thinking about these sort of one step at a time. And many of the steps and things that Michael showed you can all be actually codified and pulled into this piece. So you can take simple things like just PowerShell scripts, dump them into your design phase, build a process, click a button, and we'll automate it right off of that. So instead of having to do command shell or a whole bunch of other sort of scripts and files, you can do this visually, and I'll show you this using our drag and drop interface. I won't go into the benefits of sort of vertical versus horizontal scaling, but obviously, horizontal is all the rage, and the codification. One other additional benefit of automation is the fact that when you build your products or your applications and things in a modular way, it gives you a fundamentally better vantage point in system and platform with which to do things like horizontal scaling. And that's really, obviously, the key thing is making sure you design your applications for the cloud, because the cloud gives you that level of elasticity and things to enable things like horizontal scaling. So I just have 2 more slides, and I'll jump to a demo. In Scale Extreme world, we call this stuff dynamic server assembly. And the basic idea here is that instead of baking all the components of your application, which is your PowerShell scripts and things like that, into a base image that you then upload into Azure, the idea is you should be using the common base images that Microsoft are giving you as part of Azure, because those things are tested, they're tested to work on the platform, and they're clean. Or, for instance, many of our enterprise customers build their own gold images from scratch. They harden them, they upload them into Azure, and that's the gold standard that the enterprise wants to use for all of the launches for your company on Azure. What we do, though, instead of actually taking the gold image and baking Scale Extreme into it or scripts, we dynamically install through the automation process, allow you to install the agent, but also actually install your PowerShell scripts and things. So just to tie it back to what Michael said, had talked about earlier, he used remote PowerShell as a way of injecting PowerShell content and PowerShell scripts to be running inside the Windows Server as it is launched. Well, we effectively do the same thing, but instead of using remote PowerShell, we will actually pull the content down from the Scale Extreme cloud, execute it on your endpoint, deploy your software on demand. So you're effectively dynamically creating a server off of that. And that's a single server. And then, of course, you can then start weaving this into a n-tier application. So each individual circle here, web server, app server, database tier, is represented by a process, which is a piece of software, hardening, patching, etc. And then you want to weave these through in a 3-tier model where there's data flow between them. So for instance, when you actually create the load balancer, you create the web server, you want to take the IP address of the web server and start putting it into the load balancer. Well, that's data flow, because the IP address of your web server is not going to be created until you actually dynamically provision it. So you need to take that piece of data, drop it into the load balancer. Similarly, you're taking IP addresses or inputs from each tier and weaving them together. And again, that forms what we call a process, which then gives you an n-tier application. And again, going back to sort of what Michael said, when your boss comes and says, you know what, I need this exact same thing, and I want you to punch this out like pancakes, this might be a testing environment, maybe developers come, you need 5 of these environments for each developer, you need a staging environment, you may need a production environment, plus maybe a disaster recovery site. Once you've actually built this model out, and you've weaved your PowerShell scripts together, or whether if you're running on Linux, you're doing shell, all of this stuff actually becomes completely repeatable and automatable over and over again. So let me jump to sort of a quick view of what our product looks like here. So our product is a little bit different in that we actually are giving you a more flexible, simpler, but more, how do I say, loosely coupled environment than some of the other ones there. So the basic idea is I have, in this particular demo, a total of 10 servers running across actually a couple of different clouds here. So if you actually go to our Manage tab, we've now linked an Azure account, and it's actually very simple. If you go set up that free account, you can just go to Add Cloud Provider, and it will give you a list of all the clouds out here. Here's Windows Azure. You just say Add Provider. And you basically, once you give us a link to your profile, you just upload it, and it immediately links your Azure account directly into your Scale Extreme account. So your Azure account is here. If you have an EC2 account, you may have some actually local machines. Even if you have some on-premise machines, you can just download the agent here. And we support pretty much every OS out there. Let's see what happened here. All right, so a whole bunch of operating systems. You just grab the image. It's a zero configuration installer. You drop it on there. It does certificate-based authentication, registers into the cloud, and you're on your way. So all of this stuff should take you less than 10 minutes to actually set up. So all your servers are basically going to show up here. And this demo that I'm doing on Azure, I'm actually going to do an all Linux demo for you, just to point out the fact that one of the things that Microsoft have done really well is the fact that Azure runs Linux and cross-platform software just perfectly well. I'm actually running this demo, obviously, off of Mac in Chrome, running with Azure on Linux machines. So this could be the most probably non-Microsoft demo here at the entire conference. There's a prize for that. So let's talk about automation, because I know the focus is on that. So what you do is, in our product, you have library and operations. Very simple. Library is the place where you go, where you would upload Michael's PowerShell scripts, for instance. So in this particular case, I'm actually going to demo this thing called React, which is an open source database out there. This happens to be done in Bash. So I actually have a script here that I've uploaded, and it's very simple. You just say add script. You drop the content in there, and it goes into my scripts. Now, these become the building blocks of pretty much everything you're going to do. So each atomic operation, which is things like installing React or configuring something or doing a particular download of something and configuring it, pretty much everything that Michael's scripts could do, you can upload those as atomic steps. And the second thing you do then is create a process. So a process is nothing but effectively a runbook, so to say. So I can pull that up, and you have 3 things here. You have startup, operational, and shutdown. Startup are all the things that you're going to do when you set the machine up the first time. So this stuff only runs once. So it's all about installing the software, configuring it, whatever you want. And operational things are things that actually run on a routine basis. So you can set a schedule up. So a great example could be you have a database system. Once you set it up, you actually want to back it up every week or every day as a operational piece so that you don't forget it. So the next time the next person actually deploys this piece of software, they don't have to add a backup step as part of that. You would add that as part of an operational step. And at this point, all you do is you basically grab a launch machine step. You can then actually do things like, for instance, register it to a load balancer. You can then start picking up installer scripts like the React installer script here. And all of a sudden now you're constructing a process which is nothing but a series of steps, which are automation steps. Again, very similar to what Michael did by hand using PowerShell. We're actually just doing it in a visual way. And then once you save that, you have a process that you can just keep running over and over again. So I'm going to cancel out of this just to kind of show you this thing running. So we have this process here, which is a React installer. And thankfully, my engineering team helped me build this. It's got about 11 steps to it. This initializes the cluster. And notice this is a process within a process. So you can actually use, this is kind of like Lego blocks. You have the basic Lego blocks, which are steps. You can compose a process. And then you can build a process out of multiple processes. So this init cluster, basically what it does is it launches a machine here. And it then does an installer. Has inputs and outputs, as you can see. There are pretty much no inputs, a couple outputs here. Similarly, there's an input here, and notice, this is actually really interesting, notice that the input from here that I'm highlighting came from a previous step that was dynamically launched. So the node IP of this that goes into this installer script came from the launch step that actually launched the machine. So it launches it, grabs the IP dynamically, data flows it out to this particular step, uses that as an input, the script actually uses that IP address, bakes it into the machine, and voila, you're in business. So I think you get the basic idea. And once I basically go through and launch this, I can actually just click this launch button, and it says, do you want to schedule this for now? Do you want to actually schedule this for, let's say, Saturday, if you're expecting load or something in advance? So once that happens, I'm not going to actually turn it on and wait for that. We have obviously a pre-running one here. And this is the operations tab. So this is where you go to actually see the results of the work that you did. So as you can notice, and this is actually pretty cool, is we've launched this particular stack, you can tell, a number of times. So this is the example that Michael was talking about where your boss comes to you and says, hey, give me another one. And, oh, I need another one, and a third, and a fourth, and a fifth, and a sixth. Well, all you're doing is just punching the launch button each time, entering some input variables based on how you've actually written your code and modularized it. But each one of those deployments actually results in a full React cluster on Azure, each time running in a separate cluster. So let's go to this one here that says React Azure install. I'm sure this is the one that's set up for the demo. And notice we actually have 3 nodes running now. And you get, nice little sort of graphs here. You can just look at the status of what's going on. 0 problems, which is a good sign. All the startup processes ran. And we can actually dive into what happened here. So on the startup side, there was, these are the ones that ran. So these are all the 3 sort of startups and processes that ran. So here's the init cluster. Launched the machine, did the install, the base config. And of course, the shutdown's not running yet because we haven't shut the thing down. And this particular machine that got launched, the single instance, is running just fine. And then what we can do is go back to the add nodes piece. And notice now, on this particular one, we have scale up and scale down buttons. And the basic idea here is now I've got this React cluster, things are going great, but I could actually go ahead and start scaling up. And what this allows us to do, and this is actually a very cool feature we've added as part of Scale Extreme. One of the core tenets of our product is the ability to manage pre-existing machines or systems. So you don't have to, in Scale Extreme, you don't have to keep relaunching servers each time you want to scale up or scale down or do an operation. You can actually pull a pre-existing machine into the system and say, you know what? I want to take this thing over here that I actually just created, pull it into the pool, and promote that to be part of the pool of stuff that's actually running. So I can actually grab an existing node or run the exact setup process, if it's stateless effectively, run it again, it just adds it in, and it scales up. So that's really sort of the core idea here. And once you're now off and running, these machines are actually running here. If you go back into the Manage tab, notice these 3 machines are here. And you can actually operate and deal with these machines on an individual basis as well. So our product is one of the few products out there that actually offers cloud-based patch management. This is actually a big sort of high runner product for us that a lot of people love. I can actually go to any machine here. Here's sort of a patch tab that gives you a bird's eye view of patching all of your Azure machines, your on-premise machines, your EC2 machines, etc. This gives you a simple way of running reports, things like that. Here's the monitoring product. You can actually go directly into it over here. And it offers some very, very deep, not only system-level monitoring, but also application-level monitoring. So, for instance, these are all the alerts that I've actually set up here. And then here are a set of applications. This is the base operating system. Whole bunch of database stuff. So Memcache, Mongo, MySQL, Redis, obviously, a couple of other things, Apache, Nginx. And each one of these you can actually go in and very, very detailed stats. So each one of these items here can be thresholded, alerted. You can run actually automation processes based on things going down or up. Changes, things like that, JMX. And for Windows, we offer, obviously, the usual suspects, IIS, SQL Server, actually even Exchange, all of Windows services. Everything can be independently monitored, independent of sort of the automation pieces. So one cool part here, I'll actually just give one shout out here. And Michael, let me know if I'm kind of running out of time. But here's an example of being able to start tying in automation with alerting. And that's actually one very, very key thing, as all of you know, is that part of running any of these sort of automatable, scaled infrastructure, the monitoring system is a bedrock of automation to a very large extent. Whoa. Okay. Am I supposed to hit the buzzer or? So anyway, so here's just a really small example here. So based on these conditions, which is this is a storage alert here, I can not only do notification, but I can actually run a process or run a script from the library. So this is an example of where, for instance, on this particular trigger, let's say a low disk alert, I can actually go ahead and pick one of my little scripts or things here that basically will now, let's say, clean up the server. So let's say you're generating a ton of logs and you're just running out of disk space all the time. You can just go in and run a canonical script that will start clearing out your temp files and things like that off of that. Or, for instance, you can actually do sort of simple automation, which is you're running out of disk space or running out of capacity or something on there. You can actually go ahead and then run a particular process that allows you to then start actually running any script or any multi-step process that you actually delivered or run there. So let me actually wrap up here just by sort of summarizing everything. So the basic idea in the library, and again, tying that back to what Michael had said earlier, because I think it'll sort of help you think about this the better way, is any script that you have, it could be PowerShell, it could be shell or whatever, you can drop it into the library as a step. So one of the key things, again, in automation is breaking out these things into very small little Lego blocks that can run independently typically, and then you can reuse them over and over and over again. So breaking these things into little building blocks, and then once you have the building blocks, weaving them into a linear or sort of loop-based process here. Instead of writing PowerShell scripts, you can use a product like ours to actually visually automate this stuff into a repeatable process and then just launch away. And that's really sort of the key of automation, I think, is really that basic stuff. So thank you. Again, encourage you, if you're using Azure or running Azure, set up a free account with Scale Extreme. There's free monitoring there, but patch management, automation in the works. So
awesome.
Hope to hear you.
Thank you very much, Nan.
Thank you.
All right. So just to kind of wrap everything up, you guys saw kind of a core overview of what Azure provides out of the box from an automation perspective. We had some really good, deep, detailed information from RightScale and Scale Extreme. So all this in an hour and 15 minutes. I hope we lived up to your expectation of being a true crash course. So if you do have any questions for us, we're going to be available for a few minutes afterwards, and we're probably going to wander over to the Windows Azure booth over in the Expo Center once they open up at 11. So thank you very much.